The diagram shows a sketch of the curve y equal to function x. Okay, you can see the sketch over here, and from 1 to 5 has been shaded. The region under the curves between x equals to 1 and x equals to 5 is shaded as shown in the diagram, and this area is given as A. This region is then split into 5 vertical strips of equal width h. So that means the width of each of the strip is h. State the value of h. Okay, so what should be the value of h? And of course that should be pretty simple, right? So 5 to 1, it's a 4 units, and 4 units I have split it into, or you have split into 1, 2, 3, 4, 5. So there are 5 of them. So it should be equals to 4. You're going to divide it by 5 to get the value of h. And show using a sketch that if you take it from 0 to 4, okay, function of, right, 1 plus nh times h is less than the area of A. So let's look at how to prove that. So first, the width of each of the strips would be equals to 5 minus 1, because this is from 5 to 1. That should be a 4 units, and we're going to split it into 5 equal strips, right? Equal width strips, not equal strips, I mean equal width of the strips. So that's going to be equals to 4 out of 5, or 0.8. So that's the width of each of the strips. Okay, that's the first part. Then the question says, okay, this is h, right? And what would be the height here? Okay, when function value is a 1, so if we would substitute x with a 1, right? So this height of this rectangle is going to be f1, correct? So that value should be f1. So if I take f1 times h, that's going to give me the area of this bit of the rectangular strip. So h times f1 is the area of this particular rectangle. And what about this area? This part is a h. What about this? Okay, to the 1, okay, we have added the h over here, right? So this should be 1.08, right? Because this is 0.8, the h value. So this should be 1.08. So when I substitute f 1.08, that should give me what's the value of the y here, and that would give us what is the area of this rectangle. So f1 plus h, right? That should be the area of this rectangle. The third rectangle should be, okay, this is h, so this should be 2h. Okay, so f1 plus 2h times the h would be the area of the third rectangle. And the fourth rectangle, as you might have guessed, so it should be h times f of 1 plus 3h. And is that all, or we have one more rectangle? Yep, so this value is 1 plus 4h, and therefore altogether we have 5 rectangles, okay, which we have added together to get an approximation of that shaded area, right, by splitting it into strips. So now in each of them, what is a common factor that we can see? H is a common factor. So we can pull out the h as a common factor, and we can write this using sigma notation. When n is a 0, so we get a 0h. So that is going to give us f1. When n becomes a 1, so it's going to become 1 plus 1h, which is actually, okay, 1 plus h. Okay, can you see that? And when it is a 2, it's going to give us 2h, 1 plus 2h, which will be this term times by h, right? And when you put in 4, it's going to give you the last term, so 4h, 1 plus 4h. So f of 1 plus nh taken from 0 to 4 and sum it up times by h, and that should give you the area of, okay, all these 5 rectangular strips together. And you are told to show that, okay, of course if I multiply in the h, so I'm going to get f1 plus nh times h as what is given here, okay, which is basically the area of all these 5 rectangular strips. Is it less than the area A? That means the shaded area. Can you see here little parts that is left without being added by this area? So definitely this, the length of, I mean the area of the 5 of the rectangular strip is less than the area of A. Okay, and we have shown it, and if you showed it this way, so you would be getting 2 marks. Let's look at part B. It says find a similar expression that is greater than the area of A. Okay, the hint here is similar expression. So greater than the area of A means we are looking for an overestimation. Of course, we can't be taking F1, right? So we got to take a rectangle that is like that. Okay. So what would be the first value that we're going to take? So this value is still going to remain as H, but this time we are going to use this value, okay, in order to calculate the area of a rectangle. And as you can see, now what I am estimating is going to be bigger than, okay, the area A. So we take H times, this value would be 1 plus H, right? F of 1 plus H. So that would be the area of the first rectangular strip. The second rectangular strip would be, okay, H times F of 1 plus 2H, and then the next one would be H times, okay, 1 plus F of 1 plus 3H, and the fourth rectangular strip should be H times F of 1 plus 4H, and we have got one last one which is, okay, H times F of 1 plus 5H. So this would give us the area of, or the sum of the area of the 5 of the rectangular strips that we have. Now once again we can see that H is a common factor, so we can just pull out a H, right, and then we can use a sigma notation, but we are going to go from 1 to 5. Okay, so when n is a 1, so we get this first term, right, 1 plus 1H. When n is a 2, we're going to get 1 plus 2H, which is this term, all the way when n turns to 5, so we're going to get 5H. Okay, so this is actually how you write the area of this 5 rectangular strip using sigma notation. So now, okay, I can throw in my H into the sigma notation, and I will get F 1 plus NH times H is going to be the area of this 5 of the rectangular strips, and this should be, of course, be greater than A, right? This should be, because this extra bit here, so this should be an overestimation. So this should be greater than, find a similar expression that is greater than the area of A. This expression is greater than the area of A. Use the expression given in part A and your expression from part B to find the lower and upper bounds for the area of A. So we actually did a one underestimation as well as one overestimation. The lower bound with the H is equals to 0.8, okay, was this. I've just replaced the H with 0.8. So we get 1 times, this was a Hn, so my H is 0.8n, and we took it from 0 to 4, if you recall, right, and multiply that by 0.8, right? So this is the lower bound. So if I were to evaluate this, okay, this is going to be F1 plus F1.8, F2.6, F3.4, and 4.2, because n you replace it with 0, 1, 2, 3, and 4. So when you replace it with the 4, it's going to become 4.2. 1 plus 0.8 times 4 is going to give you 4.2. So that's what we have here. So now we can write down all the values. 0.8 times 1.05, right, because you are given function of x is 1 over 20 x square plus 1, right? So you replace the x with 1. So 1, if you square it, it's going to become 1 square. 1 square times 1 over 20, which is simply going to be 1 over 20 plus a 1, which is going to, of course, become 1.05. You take x equals to 1.8 and you put in here 1.8 squared times 1 over 20 plus a 1. Okay, that should give you this value here, which is 1.162. And f2.6, similarly, you replace the x with 2.6 and you evaluate the function of 2.6. So which is 1.338, and f3.4 should give you 1.578, and f4.2 should give you 1.882. And then you add up all these values and multiply by 0.8. So when you add up all these values, it becomes 7.01, and if you times that by 0.8, it should give you 5.608 as the underestimation of the area under the graph. Okay, so which is A. So that is the lower bound. So how about the upper bound now? Upper bound with the h is equal to 0.8. So just now for the part B, we derived the expression for the upper bound, right? So when n is equals to 1, when n equal to 2, we can replace it and write down what should be the values. 0.8 times, okay, 1 point f of 1.8, because when this is a 1, so it should be a 0.8. 0.8 plus 1 is going to become 1.8. So f of 1.8, f of 2.6, 3.4, 4.2, and the last value is when you substitute the 5, so you're going to get f5. Okay, so these are all the values. So now, just like what we did earlier for the lower bound, we're going to evaluate f1.8 by replacing the x with a 1.8 and keying into the calculator 1.8 squared divided by 20 plus a 1, and that should give you each and every one of the values. So the first value should be 1.162. The next value, f of 2.6, is going to give you 1.338, 1.578, and 1.882, and f5 should be equal to 2.25 if you put it here. And then 0.8 multiplied that by the sum of all these numbers, which adds up to 8.21. And when you multiply 8.21 with a 0.8, that's going to give you 6.568. That is going to be the upper bound value. So this is, I mean, the question asks what's the lower bound, and find the lower bound and the upper bound of the area of A. Okay, so 6.568 is the upper bound, okay, or the overestimation of the area A, okay, which is the area under the graph. Now then the next part D says, sketch the graph of the function y equal to gx between x equals to 1 to x equals to 5, for which the area between the curve, okay, between the curve, the x-axis, and the line x equals to 1 to x equals to 5, which is this, is less than this. Okay, so for you to get less than this, what should be the values that we should be connecting? Okay, g of 1 plus nh times h would be basically the area of this, right? For this to happen, okay, sketch a graph of a second function gx. So this should actually become a it should be less than, right? So it should, this area should become the upper bound. So for that to happen, of course, we are going to connect all these points, okay? That means the right value of the rectangular strips, and we can join them together and we can get y equal to gx. So this is going to be the function of y equal to gx, so that the first case underestimate now becomes an overestimate. That's what you need to do for the 1 mark.